Hello eye tracking community, my name is Michael and in this tutorial I will show you how you can make a dynamic scene static with Blickshift Analytics. On the screen we can see an eye tracking experiment where the participants had to get some information from visualizations that were distributed in a meeting room. Here on the first visualization, which is called Released Movies, we have some information. Then the participant had to write down some answers for given questions. Here's a second visualization on a projection on the wall. And then finally here, another visualization on a whiteboard. The scene is completely dynamic. So this participant is going through the room, many things, the whole perspective, the ego perspective is changing, but we have these three main visualizations. And wouldn't it be great if we could now remove the whole dynamic from the scene and visualize only the static stimuli, like the participant would sit in front of a desktop eye tracker? Wouldn't that be great? And with Blickshift, that's easy. I will show you now in the next minutes the whole workflow, how you can do that. The workflow consists of the following steps. First, we import the static images. And these static images could be photos, could be a movie when you have a presentation on a screen, for example, could also be some screenshots or printouts. The important thing is that it has the same dimension like what we can see here on the screen. As we have these markers in this case, and these markers are on the edges of the stimulus, and we need a static image which covers completely this area. And then the mapping later will work perfectly. Once we have imported these static images into Blickshift, we will have a look at the data. Perhaps we have to clean up the data. Let's see. And finally, we create some kind of a static scan path visualization, which shows us only the gazes or the fixations on this one static image or one static stimulus. So we have then removed all the dynamics from the scene. So let's start with step one. So to add the static stimuli, I go to the project manager. If it's hidden, I make just here a double click and then so I deactivate it and activate it from the menu and then I can see it again. Here we have the project manager. I go to plus media. We are here in the directory where the original data, so the dynamic data, is being stored. And here we have the three static images. I select all of them. I say open and I say OK. And here we have now the images. Next, I go to the parallel scan path visualization, the film strip visualization. I make a right click. I say visualizations and I add here a scan path visualization. I arrange the windows a bit. So in the center, we can see the export from the eye tracking software. On the left side, we can see now the same, but with a scan path visualization. So the advantage is that we can see a bit more of these fixations here in this case with the standard parameters in the visualization. And on the right side, we can see again the parallel scan path visualization. To make it now static, I go to the stimulus because every scan path consists also of a stimulus and we have always this pair here between stimulus and scan path. So I go to the stimulus. Here I change the media selection. I say column and then next I say surface gaze. Now we go to the first visualization, so released movies, and we can see it here on the left side like it would be a static stimulus. There's another thing which I have to change here. I go to the scan path. Here we still have the original coordinates from the dynamic scene. The eye tracking system of Pupil Labs provides us some special columns in the data where this mapping is done automatically for us and we imported this data from the beginning. Other eye trackers can do that as well. The column names, of course, can be different. If this information from the eye tracker is not available, because, for example, you don't want to use markers or the software does not provide this feature for you, you can also use the dynamic AOI editor and let the dynamic AOI editor create the columns which I will use now in the following. If you want to learn more about our dynamic AOI editor, please have a look at this playlist. So in case of this pupil labs eye tracker here, I can choose from the X coordinate menu now, X norm surface gaze merged, and here Y norm surface gaze merged. Now, when I look at the visualization here on the main screen, and then here on the left side, I can see, I have to change the reference radius. So let's go down a bit here in the scan path component, and let's say here 200. That's just the multiplication factor. We can see when you compare now here the yellow circle with what we can see here on the left side here, when we compare the positions, that this mapping looks quite okay. So we have this flickering here, which we can see. This comes because this surface information has some gaps here in between. If I assume now that these gaps are not correct, or I can say I can remove these gaps by some kind of a gap filling assumption, I can use the gap fill component in our software. Be careful at this point, because you change now the original data set. If you write a report, or if you want to publish the results in a paper, of course you have to mention this, that you under some assumptions changed the data model and added some new information to it. I go here to the gap fill node. By the way, there is a long tutorial about the gap fill node in our YouTube channel. Please have a look at this video. I go now very quickly through the single steps. I choose here surface gaze. So I use this quick search feature in our software. And here I say 30 lines, and as a gap value, I say none. To better understand this component, please have a look at the tutorial. Then I connect the output of the gap fill node with the already existing visualizations, which means now that the data is flowing through from the data sources, through the pupil labs transformation node, through the gap fill node, and finally into the visualization. When I go now to the PAL scan path visualization and change here the column to surface gap filled, because this is the clean data, immediately I can see these gaps have been removed and the data looks quite clean here. I go now to the stimulus, and here I also have to change to surface gaze gap filled. And then you can nicely see how in the original video, so from the ego perspective, we can see the fixation here. And as it moves around on the static stimulus, so on the projection here, it also works on this wall here, or here on the special effects stimulus. With this little workflow and the combination of these features, we made now a dynamic scene static. And from here, you can quickly go forward. Like for example, you can click on the gap fill node and choose from the menu analyses, the static AOI editor, and then you can continue with gaze statistics. And so quickly you come from a dynamic scene to a static scene, and there you can do all the standard statistics like with the not moving areas of interest. About how you can go forward from here, so how to add this area of interest editor component and how to do the gaze statistics, I will do a separate tutorial on this channel. Thank you very much for watching this video. If you like this tutorial, please push the like button, subscribe to our channel and activate the bell so that you'll never miss a new video on our channel. And I'm looking forward to seeing you in the next tutorial.